A rational number is basically a number that can be written as a fraction if you were to loosely place it that way. Okay? So can be expressed as a fraction. Okay? Whereas on the other hand, irrational number, okay, is the opposite of rational number, so it cannot be written as a fraction. Okay? So let's think of some example about rational numbers. Okay, can you give me some example of rational number? Show something out for. Yes? 3 over 4, Xavier? 1 over 2, okay, so we have simple ones, 3 over 4, 1 over 2. Would there be negative rational numbers? There is, right? Okay, so rational numbers is not just limited to be positive numbers, they can be negative as well. So in contrast, okay, we can have negative 1 over 2 also, okay. Okay, my next question is, what about decimals? Let's say if I have 0.6. Is 0.6 a rational number? Yes, right? Because 0.6 I can write it as a fraction, okay? You can write it as 6 over 10, or you can have it simplified as maybe this will be 3 over 5. Right? Okay, then of course naturally we will also have negative decimals as well, negative 1.1. Okay, then my next question is, what about a whole number? Let's say 7. Is 7 a rational number? Okay, NC says 7 can be written as 7 over 1. Alright, so naturally, because 7 can be written as 7 over 1, okay, it can be expressed as a fraction, so 7 is a rational number. Okay? Then, in primary school, we have also learned a little bit about recurring decimals, right? Okay. 0.53 with 2 dots on top. Good. Okay. Unique example. So 0.53 with 2 dots on top, that will actually refer to 0.53535353. Okay. In this case, it can be written as a decimal as it can be written as a fraction as well. Okay, although in this case I'm not too sure, need to go and think about it, but how to rewrite this into a fraction. Okay, but maybe to give a simple example, 0.535353, let's do just a simple one, 0.3 with a dot on top. I think this one we know very well that 0.33333 refers to what? Refers to 1 over 3, okay? So it can be written as 1/3. Okay, so we can have our fractions, we can have negative fractions, negative decimals. Okay, we can also have negative whole numbers, or rather negative integers, so negative 2. Okay, positive wise, whole numbers are actually part of our rational number, recurring can also be a rational number. Okay, so I hope that this is clear for us when it comes to what rational numbers are. Okay, for irrational numbers, they are numbers that cannot be written as a fraction. Okay, what is one example? Yes, pi. Okay, very good. Okay, pi is a number that cannot be written as a fraction. Do you agree with that? But then, right? Okay, if you agree with that, my question is, in primary school we learned before that pi we can use 22 over 7 to represent pi, right? In primary school, you should use to do that, right? Then are they not equal? Okay, they are not exactly the same, they are only approximation of each other. Okay? Yes, Sylvia? 5. Yeah. As in this one? Yes. But this is not a number itself, it's just simple. Yeah.
Simple, but it has a number value.
What is number value that it represents under what context? Yeah, I don't think 5 is a number value.
What about the E number?
Yeah, E is lah. Okay. Yeah, but hang on, give me a moment. Let me address this one first. Okay. So in primary school, 22 over 7 is an approximation of pi only. Okay, they are not exactly the same. In fact, if you press your calculator, something very important to note. 22 over 7 is about what? 3.1428 and so on, right? What about pi? 3.1415, okay, and then about decimals. Okay? Doesn't matter. the digit is actually different already. So in fact, 22 over 7 is more than pi, right? Okay, so this is something that we need to be clear about, that they are actually not equal. Okay, so earlier on, what Xavier actually suggested, okay, other than pi, he also said got phi. Although I'm not quite familiar with phi itself, to me it's usually just a symbol. It doesn't represent a number. But at higher levels, okay, when you go up to century, you explore more about this number e. Okay, it is an exponential number. Okay, 2 point something. Okay, so that's why later on when we do algebra, we rarely use e, okay, to represent an unknown, because e itself, okay, in our number system is a number. Yes, Sylvia.
Exclamation mark that stands for factorization.
Okay, the exclamation mark can stand for factorial, doesn't stand for factorization. Yeah, but then the factorial is not a number itself. Okay, just a symbol. That one we'll do it later on, okay, when we go up to higher levels. Yes, Xavier.
Why does it give me a number when I take the answer divided by the number?
Yeah, because 3 factorial itself doesn't give a number. You must have a number in front of the factorial to give you a number. Okay? Other irrational numbers, okay, will be maybe square root 2. Agree? Okay? Your square root number, it cannot be expressed as a fraction, therefore it is an irrational number. Then, this leads us to the next question. What about square root 4? Square root 4 is 2. So is it rational or irrational? Rational, right? Okay. So we must always consider its simplest form. Okay, so be careful. Square root 4 is actually a rational number. Okay? Yes. Okay, what question is that? Okay, that's where we can access it. Okay? Okay, is it related to our recovery? Okay, I don't know whether I can do that, okay? So, we'll run through this now, okay? So, rational number and irrational number, okay? Hope you're clear already. Okay, so now, in this entire chapter, right, we have learned a lot of different numbers, okay? We learned about rational, irrational, yes, let's see. Is this an irrational number? Okay, let's ask a good question. 109.159. Is it an irrational number? How many of you think this is an irrational number? Who would think this is a rational number? And the rest then? Ethan, what do you think? 109.159. Is it rational or irrational? You think it's irrational? Let's do a poll. Okay? How many of you think this is an irrational number? Who thinks it's a rational number? Okay, majority say rational number. You just ask irrational, I say rational. Okay, so this one is a rational number. Why? Because it is 109 and 159 over 1000, isn't it? Okay, correct, it's a mixed number, so it is a rational number. Okay, so this one. Okay, so essentially, if you want to use your calculator to help you, okay, if you have a number itself, you press your calculator for the fraction decimal button, right? Okay, you change your decimal, try to see if it can be changed into a fraction or not. Okay, so let's say I press square root 2 in my calculator. No matter how hard I press that fraction decimal button, okay, it will never be able to change into a fraction at all. Therefore, okay, if it cannot be changed into a fraction, it will be a irrational number. Yes. Okay, that's irrelevant. Okay, so let's summarize our entire number system. Okay, so in the numbers that we are covering, okay, in secondary school, they are all what we call real numbers. Okay, in case you're wondering, if got real numbers, is it got fake numbers? That's not true, okay? The other opposite idea of our real numbers, the contrasting idea, is complex complex numbers is not something that we will cover in secondary school level. You will cover it in JC if you're going for that. Otherwise, poly mathematics and higher level mathematics you also do that. Yes.
G64.
Sorry?
G64 complex number.
What's that?
It's a fake number, but it's the highest number a trader can go to before the whole screen actually just goes blank.
Okay. Xavier, I can tell, and I think the whole class can tell that you are a very knowledgeable person. Okay? But the thing is that I think we sometimes struggle with understanding what you're trying to say. At this point, I struggle with understanding what you're trying to say. And also, Xavier, I only have 40 minutes lesson. I cannot be listening to whatever you have to share with us today. Because today, must finish everything up. Okay, we prepare for WA. So, try not to enjoy our class today, alright? Okay, so now, real numbers is everything up. Okay, so if you look at your textbook, page 62, there is actually a breakdown, okay, of your real numbers. Okay, where we're looking at like maybe subsets. Okay, smaller breakdowns out of our real numbers. So we have our rational and irrational numbers as bigger branches, bigger idea. Okay, so our irrational numbers, in fact, we have already covered. What are they? Then from my rational numbers, we notice that we have so many variety out of it, okay? And we know that out of it I can have maybe my integers, okay, and non-integers. Okay, non-integers as in they are rational numbers but non-integers. So non-integer rational numbers, that's what's written in the textbook. Okay, then out of my integers, I can break it down into smaller groups. We have our whole numbers as well as our negative integers. Okay, and then our whole numbers comprises of our positive integers as well as zeros. Okay, so if I want to give some example for irrational numbers, we already had some examples just now. So we have our pi e square root 2. Okay, rational number we have our 22/7. We have our decimal, recurring or non-recurring. We even have whole numbers. Okay, then integers, we hang on and see. Okay, we also have numbers such as our -2, 0, and 7. Okay, those are integers. Non-integer rational numbers, that would be like your 22/7, 0.3, 0.1. Okay, and then positive integers, 1, 2, 3. This one just 0. Okay, so just listing some examples so that we all have an idea about our real numbers. Okay, let's see, your question was? Yes, so real numbers are just everything. Okay, all the numbers that you already know so far. Yes, David. You need to know what are. I mean, natural numbers itself is not a term that we will be using now. You usually use this terms itself. Okay, natural numbers itself essentially is just your whole numbers without the zero. Okay, questions? Alright, now do you need to go and memorize this map? You don't really need to go and memorize this integers, rational, irrational. So you need to be able to recognize them. Okay? So that's why I'm listing some examples for us to get an idea. Okay? Then, last thing. Okay, just now we were talking about recurring decimal, terminating decimal, and all that. Okay, so 22/7 itself, for example, when you press it into your calculator, sorry, let me just press my calculator myself. Okay, we have about 3.14. 2857143. Okay, I think most of the calculator will be able to produce a decimal up to this. Correct? Okay. So the problem is, does it mean that this value is exactly equals to this? The answer is no. Okay. Your calculator can only produce a certain number of digits. Okay. So at its maximum, right? Okay, which is at here, what the calculator does is that it will usually round up. Okay, but of course different calculators have different kind of programming. Some will round up, some doesn't round up. Okay, but we need to definitely know that from these numbers itself, we do observe that there is this recurring idea. In fact, okay, we notice that 142857, later on it becomes 143. Okay, it is actually supposed to be 142857. Just that your calculator reaches its maximum number of display digits already. So what they did is this number here, they rounded up to become a 3. Okay? So for 22/7, to be precise, if I want to write it as a decimal, it is actually 3.142857, 142857, 142857. So it continues as a set. And to represent it as a recurring decimal, we put a dot on the first digit and a dot on the last digit, to mean that this is being repeated. Okay? So in other words, recurring. Okay, so we only put a dot on first digit and last digit of the recurring set. Okay? We don't need to put a dot on every single digit. Okay? So that's our idea about recurring decimals. Out of our rational number system, okay, we have our terminating decimals as well as recurring decimals. Okay, so terminating decimals, we see that our fractions usually they can be expressed as a decimal. Okay, sometimes it can be written as a terminating decimal. So for example, half itself, okay, is 0.5. It stops there, so it is terminating. Okay, and then we also have numbers such as maybe negative 0.7, which is negative 7/10. Okay, so that is actually a terminating decimal. Okay, recurring decimal, as mentioned over here, we have our 22/7. Okay, and then 1/3 is also recurring decimal. Okay, or maybe numbers like maybe 123/9. You notice that the numbers just keep running on. Okay, questions? So for irrational numbers themselves, they are always non-terminating and non-recurring. Okay, because we know that the non-terminating and non-recurring means that the number just keep on going on and on and on. In fact, if you want to go and Google about pi, okay, you can have many pages of the number. It just goes on forever. Yeah, see here. It's in Google. So I think there is a website that has it more than 1,000. You can go and Google it. I don't think it's just 100. I know there was one boy who break the world record to memorize it up to like 1,000 or something like that. 1,000 digits. Yeah. Okay. Yeah. So pi itself is a non-terminating and non-recurring decimal. Likewise for the number e. Okay. How long does the sum have to go? Okay. Now, one last question. Okay, before we really wrap up our chapter 2. Okay, is that we need to know how to press our calculator. So can we all take a look at practice now 18? Okay, in your textbook. So I don't recall page 1. Can I? 64, thank you. Okay, and use your calculator to press this number down. Okay, you must know where is your value of pi. And then this question says leave your answer to 3 decimal places. Okay. So can you give it a try now? Let me write my answer on the whiteboard. Okay, you should get a decimal of about 0.58334. When rounded to 3 decimal place, you should get 0.583. Okay? Anyone not able to get this number? You raise your hand, I'll come over to you. Anybody else have any issues? Okay. If no issues, I just want to emphasize about presentation, so listen up. Okay, this question says round off to 3 decimal place. Okay, so I did check, I see your homework. Okay, I saw in your homework there are a few of you who are not sure about decimal places. It is after the decimal point, then we count, okay, how many decimal places. So after decimal point, we have the first, second, and then third decimal place. So this is 3 decimal places. Okay, in order for us to know how many decimal places or how to round off, we need more digits than that. So since we're looking at up to 3, okay, we need at least the next one, which is actually a 3. That makes us go about rounding down. Okay, that's why we get 0.583. Right? I hope that we're all clear about how we do rounding up and down. Okay? Okay? Any questions? So with that, chapter 2 is done. Alright? Yes? Okay? Now, do you have your homework with you for chapter 1? I returned to you last week, right? Okay? Yes, you all have your chapter 1 homework? Okay? Can you all take that out first? I just want to emphasize on certain things. Okay? Okay, so chapter 2 no homework. Okay. Can we all take a look at exercise 1B? Okay. I really just want to emphasize about presentation. And some of you are still not quite getting the idea about square root using prime factorization. So looking at question 1C, okay, if you don't have it, never mind, okay, you just pay attention. Yes. Notation, index notation. Find the value of a number. If you're finding a value of a number, it should be just a number, not a prime. Unless it says prime factorization, maybe index notation. Okay, maybe you go and find the question and answer. That's it. Okay, so 1C, okay, the question actually asks you to solve and find out what is square root 2916. So most of you are able to do your 2916, you do the ladder and so on. Okay, that one I will skip that step. But essentially 2916 gives you 2 squared times 3 to the power 6. Okay, maybe let me just write it down. Okay, most of you can do this. Okay, and then you are able to see that it is 2 squared times 3 to the power of 6. I think back then when we were doing this topic, right, okay, many of you are still following the exact steps, okay, that the video showed you all when you all did home-based learning. Okay, but when we came back from home-based learning, I did mention that what we can do when it comes to square root, the conclusion that we had for square root 2916 itself, okay, we are just going to divide the powers by 2. Remember that? Because okay, when we did our square root, what we understand is that 2916 is 2 squared times 3 to the power 6. Based on the video, we are trying to distribute the numbers into 2 separate and equal groups. So we have 1, 2 here, 1, 2 here, total got 2 2s. And then 3 to the power 6, we will have 3 3's over here and 3 3's over here. So that total there are actually 6 3's. Okay? So we wanted to do it this way. Then after eventually my answer will be 2 times 3 cubed. And then I must go and find out what is the eventual answer. That will be 54. Okay? So what we have arrived at so far is that there's no need for you to give me this step anymore. What you can simply know is that square root 2916 is just taking the power divided by 2. We arrive at 2 times 3 to the power 3. Okay, because 2 divided by 2 is 1. Okay, so there's an invisible 1 over here. 3 to the power 6, 6 divided by 3, 6 divided by 2, I will get 3. So I'll get this answer. Okay, I saw that in your working, so I want you to look at your homework carefully. Okay, some of you, your presentation of answer is such that you give me square root 2916 equals to 2 squared times 3 to the power 6. Then after that, 2 equals to 2 times 3 to the power 3. You give me answers like that. It is problematic because this thing itself is clearly not equals to this. So presentation-wise is not correct. Alternative presentation that some of you give me, okay, that's not correct. 2916 equals to 2 squared times 3 to the power 6. This is correct. Okay, nothing wrong with that. But after that, you tell me equals to 2 times 3 to the power of 3. Then after that, final answer 54. Then you tell me 2916 equals to 54. Clearly not correct, right? Imagine I pay you monthly salary $2,916. Because you say it's $54, I give you $54 again. Okay? So please understand the idea of equal. It must make sense from one step to the other. Okay? Yes, let's see. Question? No one? Right, so presentation wise, please do be very clear, okay, about what you need to write. Okay? Then in exercise 1B, for question 9 and question 10, okay, most of you I would likely have circled it and then indicated a P, a letter P. That is regarding your presentation. Okay, I want clear presentation that states things like length of one side. Okay, so for example, question 9. Okay, length of side or length of one side equals to square root 250. Some of you didn't compute that, that's fine. Or some of you did. So I mentioned that give me up to 3 decimal places. Okay? then the parameter will be 15.811 times 4. So we get 63.244. Final answer 63.2 cm 1 decimal place. Okay, so make sure you have your units as well. In this case, units. So what was missing are these words. Okay, your wording itself should be written at the start of your working, shouldn't be written at the back. Some of you have a habit of writing down the length outside. Okay, please don't do that. Okay, write it at the start. Right? And then you can use equal sign. Don't need to use arrow. Okay? Only very specific examples that we need to use arrow. Okay? Any questions? Alright. Then exercise 1C, generally I don't have much issues. In fact, I remember going through most of the questions in class today. Okay? Alright. We have now about, we end at what time again? 10. Oh, okay, to have WE. Okay. Any burning questions regarding your WE? No burning question? Okay, yes.
What topics are tested?
Chapter 1 and 2. Okay. All the best, Any other question? Okay, that one is burning, okay? Burn until your backside on fire already, okay? This question next time, please make sure you clear it. Oh, yeah. Okay, any other questions? Alright. I know that some of you maybe individually still have other questions you want to ask me. Okay, today, I'm not sure whether I have the time to see you, but maybe you can drop me an email, okay, and then I can reply you over the email lah. Yeah, okay, because I lesson until 3 o'clock today, then after that, 3:20 I have CCA starting as well. Okay, by the way, it happened to be Future CCA, there's no CCA this week, okay, I think some of you are in Future, alright, so I'm in charge of Future, and then no CCA this week, okay, I will inform you all again, right? Okay, let's end here today. Thank you everyone.